Okay, good morning. So for today, we're going to discuss how chemistry and the people behind it made an impact on our lives. Specifically, we're going to explore on the legacies left behind by Louis Pasteur. So for today's objective, we're going to describe how Louis Pasteur's research bridged chemistry and biology to change medicine in daily life. Particularly for our learning competency, we're going to use information from secondary resources to report how Louis Pasteur combined research from the fields of chemistry and biology, which has helped scientists to understand the cause of some diseases and prevent infections. But first, of course, before we dig deeper to our topic, let's discover some terminologies related to our lesson for today. For the first one, let's have this jumbled letters. I'm going to give you 5 seconds, or you may pause this video before revealing the answer. Do you get it? Okay, this is probiotics. Next. Okay, I think you got it. This is germ theory. Third, yes, that's right. This is biogenesis. Next. Okay, that's great. This is fermentation. Next item. During the pandemic, this term is very relevant. Yeah, this is vaccination. Next, this is, mhm, okay, this is chirality. And finally, which is the focal point of our discussion, yeah, that's great. This is pasteurization. Now, these terminologies as we go along are to be defined in each slide. Okay, but first, let's have a short background about Louis Pasteur. Who is Louis Pasteur? Okay, so Louis Pasteur is a French chemist and microbiologist whose discoveries reshaped different branches of science, particularly medicine and public health. Okay, he was born in 1822 and died in 1895. He finished his education at University of Paris, and he is known as the father of germ theory and father of modern microbiology. And one of the questions he answered from his discovery was, why does milk go sour? Or why do people get sick? So for Pasteur's earlier life, he is actually an artistic person, but his mentors and his hard work have actually helped him become a scientist. So he is from a relatively poor family. His father was a leather tanner, and in his early school years, he is more artistic than being an academic achiever. His mentors or teachers encouraged him to pursue academic study. He earned his master's degree in 1845 and he earned his doctorate in 1847, wherein he wrote dissertations, one in physics and one in chemistry. So we're going to look at the education of Louis Pasteur. He was never trained to be a biologist, but more on being a chemist. So according to some records, before becoming a legendary scientist, Pasteur nearly gave up on his studies. According to his teachers, he is a mediocre in chemistry, meaning he is not that outstanding, but he became one of the greatest chemists and microbiologists in our history. So, fun fact, he was a skilled portrait artist. Now, the science world before Pasteur. So, before Pasteur, scientists had no clear explanation for why food gets spoiled, why people get sick, or why there are tiny living things and where they came from. So, before Pasteur, the following are the dominant beliefs. First one is what we call miasma theory. It means that bad air was believed to be the cause of disease. But after pasture, germs, particularly microorganisms, can cause diseases and spoilage food. Another dominant belief before pasture was spontaneous generation. This belief, defined by living things, were primarily thought to appear from non-living matter. But after pasture, life comes only from pre-existing life, which is the main principle of biogenesis. Then, another dominant belief before pasture was no one knew what caused fermentation or food spoilage. But again, because of the experiment of pasture, specific microbes were determined to be the specific cause of diseases. And before pasture, there are no health protocols actually in hospitals. There are no standard hygiene practices, and death rates were high. And after pastures, experimentations, hygiene and sterilization were made to save lives. So this is a very short timeline of pastures breakthrough throughout the decade, wherein each discovery build lasting impact. So 1847, doctorate degree. 1854, he became a professor in science, wherein he begins his fermentation studies. 1857, wherein he were able to prove fermentation is the cause, or is caused rather, by microorganisms. In 1862, he performed his famous swan neck flask experiment, disproving spontaneous generation. In 1865, he was able to solve the silkworm industry from peregrine disease. In 1881, he was able to develop an anthrax vaccine, and in 1885, he was able to develop rabies vaccine, which was tested for a human for the first time named Joseph Lister. Okay, so you can pause this video and you can answer it at your own. So let's proceed. Now, for our next focus, we will be dealing with these four. Okay, the first one is molecular symmetry and chirality, the fermentation studies of pasture, the famous walnut glass experiment, and the germ theory of disease. So let's have the first discovery of pasture, the molecular asymmetry and chirality. Pasteur's first major discovery involves the groundwork for modern chemistry and pharmacology, and that is molecules with the same chemical formula can have different spatial structure. So if you're going to look at the example here, okay, let's say we have this tartrate crystals, okay. Tartrate crystals are byproduct of winemaking. And as he studied this in 1848, he noticed that these crystals have two distinct crystal types. Now, what are these distinct crystal types? According to him, they are like mirror image molecules, meaning to say they have left and right orientation. The two crystal types were mirror images, and this property is known as chirality. They have molecular asymmetry. Okay? And in chirality, one form rotated polarized light to the left, the other to the right. Pasteur called this optical isomerism. Now, what is the relevance of chirality in today's medicine? Many medicine must use only one orientation or one hand of the molecule to work correctly. The wrong form may be inactive or even harmful. So let me give you a specific example. So why does chirality matter today? Let's say, for example, we have ibuprofen. Ibuprofen is a common pain reliever we find in Advil and Motrin. Ibuprofen rather exists as two enantiomers. So we have active and harmful. They are identical, yet they are non-superimposable. So in the case of ibuprofen, only its S enantiomer blocks pain signal. So meaning S enantiomer, ibuprofen, is the only effective medicine or effective compound. If you're going to look at the actual chemical structure here below, you will see that S-ibuprofen is anti-inflammatory, and its mirror image structure, which is the R-ibuprofen, is an inactive compound, so it doesn't heal. Okay? Now, to sum it up, chirality affects how medicines work inside your body. It's a very great lesson from Pasteur that we still apply in modern drug development because molecule shape determines the effect. It determines how it interacts with our cells and receptors in your body. Two mirror image drugs can have completely different effects. One heals, one may harm. And another example of this chirality is in our DNA. It also affects how DNA is structured. The famous double helix turns in one specific direction only. Life at molecular level is inherently handed. So, for modern day drug approval, pharmaceutical companies must test both mirror forms of drug before they get approved. Many antibiotics, painkillers, and even vitamins depend on molecular chirality to function correctly. So in 1848, because chirality was discovered, it birthed with a new branch of drug designing, which we call stereochemistry. And that is for discovery number one, chirality and molecular asymmetry. Now let's proceed with discovery number two. Discovery number two involves fermentation. Fermentation before pasture is not believed to be a biological process, but because of his experimentation and contribution, Pasteur was able to prove that fermentation, which is a process that makes our bread rise, ferment our wine, and even the production of yogurt is actually caused by living microorganisms. So, for the background, in France, beer and wine keep turning sour, which actually provide huge economic losses to different companies in France. Now, in 1855, he discovered that specific microorganisms particularly yeast and bacteria, could drive fermentation. So his key finding involves that if you use a wrong microorganism, it could turn your product sour because it will produce lactic acid. But if you use the right microorganism, you can create wine or beer because it will produce alcohol. So where do we see fermentation today? So for instance, in bread baking or bread rising, when we bake our bread, yeast, which is a specific microorganism, is used so that it will produce carbon dioxide gas that makes our dough expand. So also, similarly, no, yogurt and cheese were created from bacteria. Bacteria ferment milk, changing its texture and flavor. Vinegar is also a product of fermentation. Acetic acid bacteria ferment alcohol into vinegar. Even our probiotic drinks, like Yakult, fermentation by bacteria and yeast creates tangy, probiotic-rich foods. And by the way, when we say probiotics, these are not harmful bacteria and they can live inside our body to help or aid our digestive processes. And even in industrial uses, the production of bioethanol, antibiotics, and vitamins are actually produced through fermentation. In our context, in the Philippines, fermentation was seen long time ago with the creation of pagoong, sukang paumbong, and even tapoy or rice wine. And that is for discovery number two. Some fermentation facts. So fermentation have been used by humans for over 10,000 years to make bread and alcoholic beverage before we knew microorganisms existed. Yes, this is true because it was Louis Pasteur who proved that microorganism is the cause of fermentation. The word fermentation comes from Latin fervere, meaning to boil, because bubbling broth looked like it was boiling. So, um, this was uh, based on the observation of early humans, because when we have fermentation, it produces gas. Next, fermentation, or rather Pasteur, for trivia number three. Pasteur discovered that different microbes cause different types of fermentation. So the product we're going to produce in uh, fermentation depends on the kind of microorganism you're going to use and the compound or the substance it will produce. If it is lactic acid, okay, you will produce something sour. If it is not, or if it produces alcohol, then you will be able to produce beer or wine. Okay, now discovery number three is very interesting because for centuries, people believed spontaneous generation. It means that life could arise from nothing. Pasteur's swan neck flask experiment destroyed this idea forever. So the main question for this discovery of Pasteur was, where do microorganisms come from? Did they appear on their own from non-living matter? Okay, so what people believe for spontaneous generation. Let's say, for example, we have a rotting meat, and that rotting meat is a non-living. Maggots will appear from rotting meat. Another example, mice were able to be born from dirty drains. Okay? Or if you left your broth for some time in air, there will be microbes and it will get spoiled. So in 1859, he entered a competition to test this theory. And it was organized by the French Academy of Sciences. Now his tool is this image. It is a glass flask with a long S-shaped curved neck, hence the name swan neck flask. So what did he do? Okay, so this experiment involves application of heat. Okay, so pasture boiled broth in flasks with long curved swan neck openings. So if you can see in the diagram here, we have three setups. So on the first setup, he applied heat. He let the flask sit, but no bacteria was present. Okay, so there are no microbes on the broth. On the second uh, setup, he also do the same, but he removed the neck and let it sit. What did he observe? After some time, bacteria was present. On the third setup, he also applied heat, but he only tilt the flask sideways and let it sit. And bacteria were present. So we're going to look at the second setup and the third setup, and you compare it with the first setup. What did he conclude? Okay, so for the first setup, the broth remained clear and free of microorganisms for months. But when the neck was broken off, microorganisms appeared and broth spoiled. So his major conclusion was microorganisms came from the air or the environment and not just a vital force or spontaneous generation, meaning to say the broth did not produce those microorganisms. It was the air containing microbes who made the broth not clear and free of microorganisms. And from this experiment, we were able to support the what we call biogenesis, for the non-spontaneous theory of life. It's a principle that life arises only from living things and not from living matter. So we're going to return from the previous um, belief that life could exist from non-living things. Then therefore, pastors were able to disprove that belief. Next, for discovery number four, it's actually connected with disproving the spontaneous theory. He, Pasteur were able to develop his germ theory of disease. According to him, specific microorganisms cause specific diseases, which transformed the medicine and the foundation of modern microbiology. Let's say, for example, specific microorganisms like bacterium, virus, or parasite causes specific infection in the body because these microorganisms enters and spreads in our body, which leads to specific disease, which are observable illness in the patient. Let's say, for example, tuberculosis is caused by Mycobacterium tuberculosis bacteria. Cholera was caused by Vibrio cholerae, and rabies was caused by rabies lyssavirus. So, what are now the key implications of germ theory? So, building on fermentation work and swan neck flask experiment, Pasteur formally proposed germ theory in 1864. Before germ theory, doctors believed miasma or bad air was the cause of illness, but germ theory replaced this entirely. It explained why wounds become infected, why diseases spread between people, and why some environments cause illness. So the key impact is that it led directly to what we call antiseptic surgeries, sterilizations, and even vaccinations in hospitals. So before Pasteur, we have miasma theory, and after Pasteur's germ theory in 1864, these are now the things that have changed. Microorganisms cause infectious diseases. Examples of these microorganisms, bacteria, viruses, and fungi. These specific germs are the cause of specific diseases and not just the vague by air. It's proven through extensive experiments, including the swan neck flask experiment, because it changed medicine, surgery, and public health forever. Okay? So before germ theory, surgeons operated without gloves or sterilized tools. But after theory, Joseph Lister introduced antiseptics in surgery. Antiseptic invention by Joseph Lister was inspired by Pasteur. Before germ theory, infections after surgery were extremely common and often fatal, but hand washing and sterilization became a standard practice after germ theory. Before germ theory, hospitals spread diseases actually rather than curing it because they don't know hygienes and health protocols. But after germ theory, hospital infection rates dropped dramatically because of the established health protocols after Pasteur were able to establish his germ theory. Okay, so let's try matching these terms with their definition. You can do this for 5 minutes. You can pause this video and try to answer these exercises. And then after some time, you can start the video and I'm going to reveal the answer on the next slide. I hope you got it right. Ta-da! Okay, so for number one, it's letter D. For number two, it's B. For number three, it's A. For four, it's E. For five, it's C. And for number six, it's letter F. Okay, so I'm going to cut my recording here, and I hope you've learned today. I'm going to continue the recording and upload it on the YouTube channel. So I hope you learned a lot today, and see you on discovery number 5.